Okay, I think we can start now. So let me see this one. Yeah. So good afternoon, everybody. So last time, I told you that any instruction should have a mnemonic. This mnemonic should tell what this instruction is doing. Is that addition, multiplication, whatever. Also, it should have operands. Okay. So these operands should tell you the source of the data needed for this instruction. Also, it should tell the destination where you are going to store the result. Okay, the destination. And I told you for operands, we have one of three options. Only one of three options. One operand, it can be register. So your data is coming from a register, or it can be a number. We call it immediate value or a number, similar to what we did before in C language, I equal I plus 5. So it's like 5 here, number 5. In case of a register, your data is stored in a register. The third case is memory. So your data is stored in memory, okay? And in case of memory, I'm gonna explain 3-4 different ways under memory, okay? 3 different ways. All of them, you have to use a square bracket, okay? Why I'm teaching this part? Because that's what I'm gonna use in all instructions, at least to remove any confusion. If you have an instruction, you should know where are the operands of these instructions. You should understand them, okay? So I told you last time, in case of register, so here registers, you can, as you see here, and as you are going to see later, in case of register, we just use the name of the register. Is that okay? So for example, as you see here, I want to add register 2 plus register 3 and to store the result in register 1. What this means? It means whatever in R2, whatever in R3, whatever value stored there, they are going to be added together, okay? And the result is going to go to R1. So after you execute this instruction, R2 and R3 are not going to change because you just copy whatever is there. And then you add, you actually copy them or you actually send them to the ALU. So the ALU is going to take these 2 and then store the result in R1. Okay, very easy. Also, in case of if it is an immediate value means a constant value. Constant. So your data is just a number, right? It's not stored anywhere. It's just a number. Okay. Anyway, it's not the content of a register. It's not the content of a memory location. Just a number. Okay. Like for example, this case in this here, I want to add R2, whatever in R2. So whatever in R2, I'm going to add it all the time to number 4. Okay. And when I store the result in R1. In this case, you have to put, as you see here, you have to put hashtag before this number. So once you see hashtag a number, that means this is an immediate value. Is that okay? Then after that, memory location. Okay, guys. For if your data or if your operand is a memory location, you have to give me the address. That's it. You have to tell me what is the address. Okay. Once you give me the address, for example, if you give me 2000, okay, if you want to read, I can read. When I say address, as I said last time, I mean the base address, because if it is a word, so it's going to be stored in full location. The base address is the beginning address, okay? The smallest one, okay? So here, I can go there and read full location. I can read the word. The other option is, if you want to write to the location at 2000, so whatever number I can write it there. Okay. So for memory, I told you how many formats you are going to have for memory. Again, for all of them we use square brackets as you see right now. So the first format, if something like that. Okay. So here use a register as a pointer. So here, if you see something like that, as you see here, what this means? It means I want to copy a word. I want to copy a word from memory. Every time you see square brackets, that means it's a memory. So I want to copy from memory and store it from R1, store it in R1. Is that okay? Again, as you will see right now, all the different types I'm going to explain, all of them have square brackets, number one. Number two, all of them are storing address in one of the register. That's number two. They are different in, as you will see right now, some of them change this pointer, R0 here like a pointer. Some of them changes the pointer, some of them don't change the pointer. Okay. Here, as you see here, R0 is a pointer. So if I want to read the word from location 2000, so R0, I have to put in R0 2000. So R0 is a pointer because R0 is not storing a value. It is storing address of the value I want to read. It's not storing the value. Okay. Here, when I use R1 here or R2 here, so the value or the data itself, it is just inside the register. But if you use a register as a pointer, so actually your data is in the memory, but the location is stored in this register. Okay, guys, is that clear? Any questions? Okay. One more thing. So this is the first one here, as you see here. The second one, we call it register offset. So here we are going to use the idea of offset. So what do you mean by offset? Okay. Offset means, as I told you, for example, if you have an array and this one starts from 20000, so next, this is one element. This element should take 4 locations. So next one should be at 20004. Next one should be 2008. So if I start from the base address and I want to get this is element 0, element 1, element 2. Okay. So if I start from the base address, if I add 4, okay, so now I can get element number 1. If you add 8, so now I'm going to get element number 2. Okay, and so on. Whatever you are adding here is called an offset. You understand what I'm saying, guys? So if you want to get, so here your address is actually 2000, the beginning address, plus offset. And by changing the offset, I can read different elements. Okay, so if I put offset 0, so that means I'm going to get the first element. If I put offset 4, so I'm going to get this one. If I put it 8, I'm going to get this one. If I put 12, I'm going to get next one, and so on. You understand the idea? So this is the idea of offset. Okay. So in this here, so again, you can see the difference between this one and this one, as you see here, guys. Here you can see we have only one register. Here you have to use 2 registers. Okay. I want to tell you guys, some students are confused in very small things, like, for example, most of the time I use R0, for example, just because R0, that's just everything I use R0. That doesn't mean it has to always to be R0. No, it can be any register, unless I tell you you should not use this register or whatever, but in general, it can be any register. You got what I'm saying? So here, so where is the address here? So here we are going to read the word from memory, which location in the memory, which address. Actually, in order to get the address, you have to get R0, you have to get R3 as shown here. You have to add them together, whatever is there, and this will give you the address. You have to add them together. Is that okay? This gives you, and after, and that's what I'm going to ask in tomorrow's quiz. I just want to make sure you understand what I'm explaining. That's it. I'm not going to ask you to make invention. I'm not going to ask you something too difficult. Just understand what I'm teaching. That's what I'm going to ask about. Okay. I just want to make sure you understand what this means. Okay. So here, what happens is that I'm going to read. I'm gonna read the word from the location R0 plus R3. This gives you the address. And after you execute this instruction does not change R0, also does not change R3. Same thing for this one. This one does not change the pointer, does not change R0. Is that okay? Okay. So in this case, guys, for example, how this can be useful, as I told you last time, the easy way to do it, I can put R0 can be the base address, the beginning address of an array, the base address. And then by changing R3, I can read different elements. For example, if I want to read element number 0, I'm going to put here 0. If I want to read element number 1, I'm going to put here 4. If I want to read element number 2, I'm going to put 8, and so on. So if I want to read element number 100, so I'm going to put here 400. Is that okay? Because every element you have to increase it by 4. Okay. So yes, so it's going to be so again, I said it before, but I'm going to repeat it because also you need it tomorrow. So if you have an array, so if you define an array, for example, I'm going to call it array, or I'm going to call it array, you can just any name, and then you can say DCD, and then you can put some number 7, 8, 9, and so on. Okay. So, and as I have just told you right now, you have to store the base address in R0. You have to store the base address in R0 first. Okay. So how can you do that? I explained it before. What you have to do, you have to say load register, okay, and then you have to say R0 comma equal, and then put the name of the array. For sure, I'm going to give you more details in next section, but at least here you put the name of the array. What happens is that the compiler is going to replace this one by address, and what this instruction is doing, whatever number you have here is going to be stored in R0. This is, you have to initialize R0 with the base address. Okay. Yes, and I think I give you example here. Yeah, so here I give you an example here, as I have just told you now. If I have an array like this one, for every element in this array, I want to add 5 to each element. Okay. As you will see in this course, guys, ALU, the arithmetic logic unit, only works on registers. Listen to me, okay? What it means? It means if you have to look, for example, this location in the memory, like this one, when you say in C language, array of 0, okay? So this is, I want to add 5. I want to add 5 to this location, okay? ALU cannot do it directly. Why? Because this memory location is not connected to the ALU. Remember, anything you may see something weird here. This is because hardware. So keep in mind, everything is done by the hardware. So the hardware cannot connect this one directly to the ALU. Okay. So what usually we do, you have to read this one. Okay. You have to read this one. You have to put it in a register because the ALU is connected only to registers. Okay, so you have to read this one, you have to put it in a register, and then you are gonna put here 5 because I want to add 5, and then I'm gonna ask the ALU to add this register to 5, and then the result is not gonna go here. No, the result is gonna go to a register, and then you have to write an instruction to return it back. So you will see in this course, most, if not all the operations or instructions we have cannot work directly on memory. You have to read to register, do the operation, whatever the operation is, multiplication, division, whatever, and then the result is going to be stored in the register. Then you have to store it back. That's why in any assembly program, there are 2 instructions we use them all the time, as I'm going to explain. So as you will see, even as you will see, one instruction is load, the other instruction is called to store. Okay. For now, load means I have to read from memory. All the time we use them a lot. Why? Because the ALU cannot work directly in memory. So I have to store, I have to read from memory, put it in a register, and then after I get the calculation, after I do processing to the data, now I have to return it back to memory using store. So load and store, we use them all the time. And this is exactly what I did here. See what I did. So what I did here, R0, here, R0, it has this address, and this is the beginning address. I'm assuming this is the beginning address of the array. So I'm not gonna sorry, this is R1. I'm not gonna change R1. So as I told you, so R1 is pointing on the base address. all what I'm going to do, as you will see right now, to read different elements, I'm going to change the offset. In the very beginning, the offset is 0 because I'm going to read element 0, as you see here. So here I'm going to read one element, store it in R0. Okay, so I'm going to read one element, store it in R0. This is number 1. Number 2, here I'm going to add 5 to the register. So I got the number from memory. I'm going to add 5, as you see here. So now the result is in R0. So I have to return it back using the store. Okay, guys? Any questions? So here, this one means this instruction means I'm going to read the word from here, put it in R0. But this instruction, I'm gonna store, or I'm gonna copy the content of R0 to memory. Okay, guys? Any questions? So now I am done with the first element. So what should you do next? What I have to do next, all what I have to do, guys, as I told you, I have to change this offset. For element 0, the offset is 0. For element 1, the offset is 4, and so on. And that's exactly what I did. And so in order to read element number 1, I have to add 4 to the offset. Okay, so that now the offset was here. Now the offset is going to point on next element. Every time you add 4. Is that okay? And then I'm going to repeat everything again. So you can see this part and this part, just copy paste. Everything I'm going to repeat, but on different location, on different elements. Okay. Then if you want to read more elements, I can do the same thing as you see here. If you want to add 4, and then I can do this part. Okay, guys, any questions? Because this is tomorrow's lab, by the way. So tomorrow's lab, I think I give you an array. I ask you to use this way, okay, to read, to copy the array from one array to another, or something like that. Okay. Yes. You are talking this one or tomorrow's lab here? Okay, what this means? One of them, let's agree first. It means your address is the summation of the two. Okay, but if you put only one register, yeah, here, that means your address is stored here in only one. So the question is that why do I need to store the address into our, why the address should be the summation of two registers? Why? Instead of just putting it in one register. As I told you, because you can, one register can store the base address, and I'm not going to change it. So it's going to be, I'm going to constant. I'm not going to change it. Okay. And the second one is going to be, is going to change to read different elements. So if I put here 0, so it's going to be the base address plus 0, so it's going to give me element 0. But if I put here 4, the second one is called offset. So now I need to offset. Okay. So the pointer was here. Okay. If I make it 4, so now the pointer is here to read this element. If I make it 8, so now the pointer is here to read this one, and so on. So one of them I'm going to fix it, the base. The other one I'm going to add offset. I'm going to add some value in order to go to anywhere in the array. Is that clear now? That makes sense, because that's a good question. So for example, if my array has three elements, so I should not read more than 3. I'm totally fine. Okay, especially in assembly, because if you do that in C language, maybe C language is going to give you error, but in assembly you are not going to get error. You are going to read whatever after that. So if your array is 3 elements, okay, so and then you move it to here, okay, you are going to read whatever there. You understand? Yes, you are right, but this is in assembly. If you just go to any location, read it, it's going to give you value, right? Because it's low level. Maybe if you do something like that in C language, C language is going to give you error. It's going to tell you, no, you exceeded the limit. But here, your assembly is not going to do that. Okay?
So when you're storing it back in base, the offset, and it'll begin storing offset.
When I store what? When I store some value back, it's okay. It's going to be exactly the same thing, because these two together are going to give you address. You got what I'm saying? But instead of reading, it's going to be writing. But it's exact. So if I show you the example here, yeah. So if you see here, it's exactly same thing. You got what I'm saying? But this one is going to read, this one is going to write. And now before I repeat this part again, all what I'm going to do, I'm going to move this is the summation of R1 plus R2. I'm going to move them from here to here. How you did that? Just by updating the offset. So R1 is going to be fixed. I'm going to fix R1, but every time I'm going to update R2. So that the summation of both of them is going to point on the next. Yes.
Make sure I'm understanding that line that you have circled with R2 and the one with R0 below. The only difference, the reason why R2 points to a new element is because R2 is storing an address, it's a pointer, and R0 actually adds to a value because it's not storing an address, it's actually storing a value directly.
Okay. I'm not surprised that I have a lot of questions in this part. I know it's from my experience, it's somehow confusing to students, but you will be okay, you will understand because we're going to use it all the time. So I'm happy that you have question now. So just I want to make sure I understand your question. Say it again, sorry, because I just got confused.
Yeah, so the reason why with that add R2 line,
Here, this one. Okay.
yes, the reason why that talks about it now pointing to a new element as opposed to just adding 5 to what it's storing is because R2 is storing a memory address. It's a pointer, whereas R0 is actually just storing a value directly, the value stored in the array. So when it adds, it's adding to a value, whereas R2 is adding to an address, so it's pointing to or past an address.
Okay. So I feel like you are confused between, and I have seen this in the past, between value and the address. Here, whatever you want to call it. Okay, just let me address the question. So here, R2 is a register, storing something. It doesn't matter in this case. Here, it doesn't matter. It's storing a value. It doesn't matter if it's address or I'm gonna just add 4 to the value stored in R2. Same thing here. R0 is storing something, so I'm gonna add 5 to this value. In this case, R2 is storing an offset, so I'm adding 4 to the offset. If R2 is storing an address, so in this case, address is still a value. It's just a number. Okay. So here you just add 4 to the register. Okay. So here the instruction doesn't know whatever is stored there. We don't care. Right? But here, when you see bracket, that means I'm going to read from the memory this submission, which is 2. Okay, or you are. I think so. Here you just add 5 to R0, but R0 is storing a value, so you are adding 5 to a value. Here, if R2 is storing an address and you add 4, so you are going to add 4 to the address, which is still a number. Yeah. You got that thing? Just a number. Okay, but here's the difference because that means now this is the address. R1 plus R2 is going to give you the address, and now I'm going to read the value or stored in this address. But here, you just add to register whatever is stored in the register. We don't care. The instruction doesn't need to know whatever is stored. Just you want to add 4 to this register. But here, yes, we store address here, but here we store a value. But because these two instructions are not going to read memory, they have nothing to do with the memory, right? That's why I don't care whatever is stored in R0 or R2. But here we care, right? Why? Because this is the address. The summation of R1 and R2 is going to give you address. I'm going to use the word for this address. I'm not sure if I addressed it well or still you have some confusion. You get what I'm saying? So maybe what's confusing you is that you have a register. This register is storing a number, okay? Just a number. This number can be address or can be a number. So I want to add something to this number. That's it. So processor is gonna deal with it, just a number. So I'm gonna add 4 to this number. So is this number is a register or value? It's just up to the programmer how you are gonna use it later. You get what I'm saying? Anyway, hopefully I addressed it well, but I'm not surprised. I know this part a little bit confusing with students, but hopefully you will understand it well, because you will eventually understand it well anyway. But for sure, if you understand earlier will be better. But you will, because all the time we are going to use them. We are going to use all of them. Okay. So any question here, guys? So yeah, sure. No. Take your time. That's okay.
So we added 4 to 2.
Yeah.
Then why are we still pointing at the first element of the array?
Okay. Okay. Let me go back. Let me go back to this one. Okay. Let me go back to this one to understand the difference. Okay. So what happens here, guys? Look here. Assuming I'm gonna start from location 20000. Okay. So that means next element should be at 20004. Next one should be at 20008, and so on. Is that okay? Because it's array of 4s. We agree on that, right? So what happens if R0 is here, and I wanna read from R0, so I'm gonna read this one. Is that okay? Okay. If I add 4 to R0, so now R0 will be here, and that's exactly what I did. Look here, I added 4 to the R0, so now R0 is here. When I do this instruction is going to read this one. Okay. Same thing again. I'm going to add 4 to R0. Is that okay? So what I did here is exactly the same thing, or maybe I did just very little change. So what I did now, I'm going to have 2 registers instead of 1. One register is going to be fixed. For example, R1 here, pointing at this one. So I'm going to read the location R1, comma R2. What this means? It means I'm going to add R1 plus R2. Okay. R1 is going to be fixed here all the time. R2, if I put 0 in R2, so now I'm here. I'm going to read this element. Okay. If I put 4 in R2, so I'm going to fix one. I'm going to change the other one. So if I put 4, so now the summation will be here. Then I'm going to read this one. If I make this one 8, so the summation will be here. Okay. Then I'm going to read this one, and so on. Is that okay, guys? Again, 2 different ways, but eventually I'm going to get this number. I'm going to get 2000, 2004, 2008, because this is the addresses of the elements. Any questions? Okay, let's. So actually, that's what I did. So I fix it. Here, R1 is fixed. Every time I change R2, as you see here, okay? And then once I do that, this part is identical. It doesn't matter, because whatever I'm gonna do here is gonna be the same thing. I'm gonna do this element. I'm gonna change the element. Okay, so same thing like this one, you just change the element, but for every element, I have to add 5. So it's exactly okay. So every time you want to move to the next element, you should change the offset this way. Okay. Now let's move to the next here. So this one is called register offset. Why? Because one of them is the base, and the other one here, the offset is a register. So these 3, we call them immediate offset. These 3, okay. So in these 3, we call them immediate offset because actually the offset, as you see here, the offset here is going to be a number, not a register. So I'm going to use only 1 register and a number instead of using 2 registers. Okay. Again, guys, maybe what confusing you, can I use one approach all the time or most of the time? Yes, but yes. So in some scenarios, yes, we can. If you want to read an array, you can read it in different ways. So you can use one of them all the time. Maybe yes, okay, it can all of them. But maybe in other scenarios, maybe you prefer one of them is going to be more efficient than other one. So just you need to learn all of them. Okay. So now that's why this one is called immediate offset, because this one is immediate value. So let's go through them and understand before I give you examples. How these are different. First, how how they are different, how the format is different. This is the first thing you should when you see this format, you should understand what is the operand. So again, for memory, you should either you see this one, okay? So or this one, okay, if you are register offset, or can be this one here. So this one, you can see this one is similar to this one, but here we put a number, you put a pound sign and a number instead of a register. Also, it can also this one. This one is similar to this one, as you see here, but I put exclamation mark. Or it can be something, these two, this is one, this may be confusing because you add comma. Yes, there is a comma, but these two together. So once you see something, it's not two operands, just one operand, and these two together. Okay, so now the format is different. The syntax is different. Okay, so once you see the syntax, you can know which one we are using. This number one. Number two. Now let's see how they are different. Okay, here in this case, okay, so this case is exactly similar to this case, exactly, but the only difference. So here you are gonna read the location at R0 plus 4. Okay, so here you add these two numbers together. It's still the same thing. You add these two numbers together. That's it. And again, this instruction does not change R0. After executed, it does not change R0, the pointer. If you want to change the pointer, you have to write another instruction. Okay. This one also does not change R0 or R3. Okay. Same thing. This one also does not change R0. If you want to change the pointer, you have to write an instruction to do that. Okay. So again, so this one is similar to this one. The only difference, I'm gonna add a pointer plus immediate value, as you see here. Okay. So as you see. Okay. But I'm gonna give you examples. But before I give you example, I want to show how they are different. But if you put here exclamation mark, so what happens here? Look. Okay. Look between the difference between this one and this one. As I told you last time, these two are exactly similar to something we did in C language when you say y is equal I plus plus or plus plus I. You remember x equal plus plus I. You remember, or y equal. Okay. So in C language, they told you actually this instruction just a short format for two instructions. Okay. Same thing here actually. So in both of them, you are going to do two operations in one using one instruction. A y equal I and the I equal I plus 1. Okay. In both of them, you are going to do two operations. But the difference between them, which operation you have to do first, is that pre-increment or post-increment. Okay. And they told you in C language, if you put plus plus here in the beginning, so actually I'm going to increment first, and then after that, I'm going to assignment the value after increment. Is that okay? However, in this case, you are going to assign first y equal I, and then you increment I by 1. You understand what I'm saying? That's very easy. Okay. Why I'm saying this one now? Because that's exactly what we're going to do right now. So what happens here, guys? These two instructions are going to do two operations. They are the same. One operation, I'm going to read the location pointed by R0. So I'm going to read the word pointed by R0. Okay. Also, this instruction is going to add 4 to R0. This instruction is going to do the same operation. The only difference is the order. So what this instruction is going to do is going to add 4 first. It's going to update R0 first, and then read from the updated location. But this one here is going to read first and then update R0. Okay, guys. Let me make it very easy, please. Look here. You know, this instruction here is equivalent to 2 instructions. Yeah, similar to what we did in C language. So I can replace this instruction with load R1, R0. So I'm gonna read the word from R0, and then I'm gonna say add R0, 4. You understand what I'm saying? So here I can write 2 instructions. But again, this one is just shorter because just one instruction you can read and then update the pointer. And that's always what we do when you read an array. If you want to read an array, I put the pointer here. Read, update the pointer. Read, update the pointer. That's why if you see, here I have one example, and I used all the different ways in this example. You will notice that this way, it has the smallest number of instructions, compact, okay, as you will see right now. So if you see here how I'm going to show you comparison between them. So yeah, but for for example, let's look at this one, guys. I told you here what this instruction is going to do. You are going to read a word, and then you update R0, okay? So here, so as you see here, for example, if I do something like that, so what this instruction is going to do, R0 is this memory location. So I'm going to read the word from this memory location, and then I change R0, okay? As you see here. So I'm going to read R0 is pointing here. So I'm going to read the word from here. I'm going to store this word in R1, this number 1. Then I'm going to increment. I'm going to increment R0 by 4. So that next time you will be here, okay? So I'm going to show you now if I want to read this array, how I can read it. Okay, look here, guys. In the very beginning, R0 is here. In the very beginning, R0 is here. So this instruction is going to read the word pointed by R0, put it in R1. Is that okay? And then this instruction also is gonna add 4 to R0. You got it? I think that's very easy. So this instruction is going to do 2 things. After you got a number, I can add 4, I can add 5 to this number, and then I'm going to return it back to R0. Okay. I think there is some mistake here. I need to check because R0 is already updated. So I think you are going to write it in a different location. So this example, so when you read it back, so already R0 is updated. So I think this example is not, you are going to write in a different location. You're not going to write to R0. So I'm gonna correct it and give it. I'm gonna correct it, and it shouldn't be this way. You have to use another pointer or something. I'm gonna correct this example in a way, but that's not what you need tomorrow. What you need tomorrow, you need this one, and you need to store for another location because what you are gonna have tomorrow. But I think that's not correct because R0 is gonna be updated here. When you write, you are gonna write a different location. So I'm gonna change this example. Okay. Anyway. But what you are going to do tomorrow, I'm giving you 2 arrays. You have one array here and one array here, okay? This array has some numbers, like for example, A, B, C, it has some numbers. Is that okay? And this array is empty array. And I want you to copy this array to this array. So you have 2 arrays, okay? I want you to copy one array to another array, okay? The way you have to do it, for it, you have to use 2 pointers, not 1, 2 pointers. Why you have to use 2 pointers? Because 1 pointer for each array. Make sense? For example, I'm going to use here. R0 is going to be here, or R1, whatever you want to do it. It doesn't matter. R0 is going to be here. So you're going to have 2 pointers. Okay. So what you have to do in the beginning, I have to say, I can use this one here. So I can let me write it here. For example, I'm going to say load R1, comma R0 and 4. So what this instruction is going to do? This instruction is going to read this value, it's going to store it in R1. That's okay. And then it's going to update this one for next time. Okay. So now what I did, I read this element, I store it in R1. Okay. Now I have to copy. Sorry, let's use something else other than R1. R3, for example, because R1 is going to be used as a pointer here. So now I want to copy this value here. Is that right? That's what I'm going to do. Look here, guys. One pointer is here, pointer is here. Copy this one to this one. Now increment the 2 pointers. Copy this element to this element. Now increment these 2 pointers. Copy this element to this element. That's what I'm saying. So, and now, so what I did, I'm going to read this element. I'm going to store it in R3. Now I'm going to use the store. I'm going to use the store of R3. The element I already read, put it in R3. So I'm gonna say go to R1 and 4. So what's gonna happen here? The element, this element, I'm gonna store it in R1. It's gonna come to here, and also I'm gonna increment R1. Okay, guys. So I am done with the first element. Okay. Okay. What about the second element? The good thing here is that for the second element, I'm gonna just repeat these 2 lines. That's it. But this time, when you repeat these 2 lines, this time I'm gonna work on this element and this element. You understand? I'm gonna copy, and also this 2 is gonna update. Okay. What if I wanna read the next element? Just repeat them. You understand what I'm saying? Any questions? Okay. So I'm gonna fix this example. Yeah, this part is okay, but you are not gonna write because you already changed it R0. Okay. So this is, yeah.
Store R0 into R1.
Yeah, if you want to do something like that, maybe this approach is not the best way, or you can use another pointer, because now you update it R0. Okay, so when you come here, you are not going to be to the same location. You change the location. So what you can do here, okay. Yeah, I understand what you want to say. We can do very little fix here. Okay, so what you can do, I can remove this one from here. I can put it here. Now everything is okay. You got what I'm saying? So I'm going to read the word from the location pointed by R0. And I'm not going to change R0. Right? And then once I come to here, I'm going to add 5. And then here, I'm going to store this value in R0 and then increment R0. Yes. So yeah, I'm gonna do this fix. So repeat it here as well. So I'm gonna repeat it everywhere. Yes. So I'm gonna update here, not here. Yes, because I'm gonna use the same address. Any question? Is that clear? Okay. So now let's look at this one. If you see this format here, yeah, without, yeah. So here, as I told you in this one is called the pre-index. In pre-index, as I told you, the address is R0 plus 4. And this instruction does not change R0. Okay, that's what I'm going to ask you tomorrow in the quiz. In the quiz, I just want to make sure you understand, number 1, how the instruction works. Okay. Number 2, do you understand which instruction, if this instruction is changing the pointer or not? So this one does not change R0. This one does not change R0 or R3. Only these 2 instructions that are going to change the pointer here. Is that okay? So anyway, so let's see this one. Yeah. For example, here, guys. So here, as you see, for example, in this example, if R0 is this value, okay, and I want to read the word from a memory location, which location is going to be this value plus 4. So it's going to be this value, okay, plus 4. Yes. So this will be, so I'm going to read from here. So I'm going to read the word from here. When you read the word from here, it's going to be actually four locations. That's exactly what I did. That's what I'm going to read. And after executing this instruction, R0 will be the same. This one does not change R0. It's going to take whatever in R0, it's going to add 4, and this will be the address. It's going to come to here. Okay. Anyway, if you want to use this one to read the array for some reason, if you want to do that, okay. Yeah. So for example, one way, again, there are different ways, but one way to do it, if R0 is already R0 is pointing at the first element, so I can use this one to read the first element and then at 4. If you want to read the next element, I can put here the offset 4 in order. So here again, there are different ways to do it, but if you want to use this format, I can keep it this way. I can say R0 here, and then I can say R0 plus 4. And then if you need to read next one, So here I can change this number to 8. Yes, I can keep it this way. There may be another, so you can do this way to read the different elements. There may be another way. For example, I can do it. For example, this is my array. We start to, okay. So what I'm gonna do, I'm gonna put R0 here. So 4 elements here before. So before the beginning of the array, I can put R0 here, and then by this way, this one here, R04 is gonna read this location, okay? Because this one is gonna add 4 to R0. So if I put here R0 4 bytes before the beginning of the array, so if you use this one, you are gonna use the beginning. You are gonna read the first element. After that, you can increment 4 to R0, increment 4, and if you want to read the next element, okay, for example, I can put, every time I put R0 in somewhere, so I'm going to read the next one because you add 4. Okay, guys. Again, there are different ways. So I'm saying if you want to use this one, there are different ways. You can use this way, or you here, because you have to add 4. So I cannot put R0 in the beginning. Otherwise, if you put R0 at the beginning, you are not going to read the first element because it's going to be R0 plus 4. That's how it works, right? So if I want to read the first element, I can put R0 just 4 bytes before the beginning of the array. And then every time you read, you need to update R0, but this one does not change R0. Anyway, there are different ways. Yeah, for this one is gonna update R0. So you don't need to write an instruction to update R0. But also you have to be careful here because this one is not gonna read at location R0. This one is gonna read at location R0 plus 4. So for example, if I want to read an array, you should not put R0 here. If you do that, you are not gonna read the first element because this one is gonna update R0 first. So it's gonna add 4 first. So I'm not gonna read the first element. So if you want to use this one, what you have to do is that you have, if this is my array, if this is array is here, so you have to put R0 here, which is 4 element here, okay? So that if you put it here, what this instruction is gonna do is gonna add 4 and then read. If you use the same instruction again, you are gonna add 4 and read, add 4 and read. You got what I'm saying? It's not good, a little bit confusing, but it's not hard. Okay, it depends on what the instruction is doing. So if you read first and then you add, so I'm gonna put R0 here to read and then add. But this instruction is not doing that. This instruction is it's gonna add 4 and then read, add 4 and then read. So you have, when you initialize it, I have to initialize it 4 bytes before the beginning. And I told you in the lab, all what you have to do, you have to initialize R0 with the beginning address of the array. And the way you have to do it, you have to say load register R0 comma equal array. By this way, R0 is at the beginning of the array. Okay, if you want to keep it this way, if this is good for you, that's okay. However, in this case, I have to put it 4 bytes here. That's why I told you have to use subtraction instruction. I give you the instruction, so you have to subtract. This is in the initialization because I don't want to start from here. I want to start from here. So once you read this one, once you read the beginning of the array using this instruction, you need to subtract 4. And that's what we are going to do tomorrow. Again, there are different ways. I'm not saying this is the best way, but yeah, this is one of the ways. And then after that, after you do the initialization, so now I initialize R0 here. After I do that, the good thing about this instruction, I don't need to write an instruction to update R0 every time I read one element, okay? So once I do the initialization, that's it. So if I use this one, you read one element. Use it again, you read next element. Use it again, you are gonna read next element, okay? Because the pointer is already updated here, okay? So, and that's what I'm explaining here. Look here, guys. So I'm gonna read array here. Sorry, I think that's yeah. So here, yeah. So here, yeah. So here I did it a little bit different. What I did here, I'm gonna start from here, but I'm not gonna use this format. I'm gonna use this format to read the first element. So R0 here, which is also totally fine. So there are 2 approaches, okay? One approach, I can just put R0 here, guys, and then I'm going to use this one to read the first element. After the first element, I'm going to use this one here. So when I read the second element, what this one is going to do is going to add 4, read this one, add 4, and read this one, as you see here. Okay. This is, you can do this way, it's totally fine, but there is another way. As I have just told you now, you have, instead of putting R0 here, okay, I'm going to initialize it with here. Okay. And I'm not going to use this approach. I'm going to just, for the first element, this one is going to give me the first element because you add 4. Hopefully, I didn't confuse you. What I'm saying, guys, it depends on where you are going to put R0. If I put R0 here from the beginning, so I can just use this one to read element 0. And this one, I can use it to read element 1, 2, 3, 4, 5, and so on. But every time it's going to add 4, read, add 4, and read. Okay, this one approach. The other approach, I can use this one all the time, element 0, element 1, element 2, element 3, and so on. But this time, if you want to do it, you have to make sure R0 is 4 bytes before the beginning, because once you add 4, you are going to hit the correct location. You add 4, you hit the correct location, because that's how it works. You just, every time you add 4. Okay, guys, any questions? Okay, you have a lot of numerical examples here. I hope this example should help you to understand the topic here. Okay, maybe I'm gonna go to this example here to explain it to you. If you want to do something like that in C language, okay, as you see here, guys. For example, I want to say x is equal to this one here. X is equal to -2. Okay, and then what I want to do here, x is equal x plus 1. So if I want to do something like this one, okay. So here you do here initialization. You initialize x. So if you want to do something like that, as you see here, guys, you have to define, as we did before, I have to define a variable. This variable, you have to define a variable, and you have to put initial value here. I think there is also, so I think, yeah, this one should be -2, not -1. So -2, and this one should be D instead of W. Okay. Anyway, I'm gonna fix this one as well. So this is because it is a word, and I want to initialize it to -2. Okay. So this one, what I want to tell you here, guys, this one here is equivalent to the initial. Is equivalent to when you define a variable and initialize it. Okay. This one here. But again, this one should be -2, just to be similar from here. And this one, I'm going to use it as a word. Not half a word. Anyway, so I'm going to fix it. One more thing here. Now, how can you do this addition? Okay, as I told you, X is a memory location. Add an instruction, and add an instruction cannot work directly on the memory location. So I have to read using load, and then I have to add 1, and then I have to return it back. That's exactly what I'm going to do. So as you see here, guys, number 1, I have to read. Add 1, I have to read the value of X, okay, add 1, and then I'm going to return it back. But in order to read a memory location, I have to store the address in a pointer, and that's what I did. So number 1, see, what this instruction is going to do, this instruction is going to store the address of this variable X here. So R0 should equal the address. Okay, guys? Then you are going to read the value here. You are going to read the value from the memory. Then you add 1, and then you return it back. Okay, guys? So R0 is a pointer. Okay. So R0 is storing the address of the variable X. So now I know what may confuse. What is the difference between R0 and this one? Yeah. This one is going to give you the address of X. You have a variable X. This one is going to give you the address, but this one is going to give you the value of X. Is that clear now? Any questions? Great. Also, I give you here another example. As I told you before, if you have a variable, you need to decide if you are going to use a register for this variable or you are going to use memory location. Both are okay. But if you wanna your program to be fast for high performance of your program, if there is a variable you are going to use it many times, it's better to be a register, because reading or writing registers are much faster than memory location. So here I give you in this example, if I want to do something like that in C language, if I want to do it in assembly, okay, one way to do it, I'm gonna use R0 for X for variable X. I'm gonna use R1 for variable Y. I'm gonna use R2 for variable Z, as you see here. Okay. Now, if I want to do something like that, so I'm gonna add register plus register, store the result in a register R0, R1. So I can do something like that. Okay, guys. So now in this example, I'm using registers to store the variables. Okay. Okay. Now. You may decide to do it in a different way. Instead of using registers, I'm going to use memory location. So here, this one is going to be in memory, this one is going to be in memory, and this one also is going to be in memory. In this case, how can you add memory location plus memory location and to store the result in memory location? Again, all the instructions we have are not going to work directly on memory locations. So I have to read this one, put it in a register. I have to read this one, put it in a register. I have to add them together, put it in a register, and then return back the result to memory. Is that clear? That's exactly what I did, as you see here. Here, I'm assuming you already put the address of X in R0. So now I'm gonna read X. I'm gonna read Y, as you see here. Then I'm gonna do the addition. Then the result, I'm going to store it in R2. The result is I'm going to store it in Z, in the memory location pointed by R2, which is Z. Okay, guys? This is the part was somehow hidden from you mostly in C language. In C language, you define X, and then you can use X all the time. You don't need to worry about it. Where is X? Where it is stored in memory? You might not need to worry about this. Just use X. And everything else is going to be done by the compiler. It's hidden from you. You understand what I'm saying? Any questions? Okay. Maybe also I want to explain this program here. Although maybe I didn't teach most of this instruction, but let's see this program. In this program, as you see here, guys, I have here, as you see, I have two strings. As I told you before, any string or message is just array of bytes, as you know. So this is array of bytes. This one is array of bytes. Okay. So here you can see it like you have two array of bytes, two arrays of bytes. This is the name of this array, source string. This one is called destination string. Okay. So it's like you have two arrays. Okay. And now, the reason I want to explain this one, because this one has somehow close to what you are going to do tomorrow somehow. Okay, but so here you have two arrays. You have a pointer here R1. You have a pointer here R0, and then I want to copy one array to another. So all what you have to do, I'm gonna read this one. I'm gonna put it here. Okay, and then I have to update R1. I have to update R0. Then you have to keep doing this. Okay, so we have two arrays. So this one is going to point two pointers, right? One pointer here, one pointer here. Then copy and then move the 2 pointers. This one is going to point at element number 1 here, element number 1 here. Then you copy, increment the 2 pointers. So also, you should understand here you should not add 4. You should not add 4 here, because this is not array of words. This is array of bytes. You have only to add 1. Okay, that's exactly what we're going to do right now. So as you see here, what I'm going to do, R1 here, this instruction is going to store the beginning address in R1. This one is going to store the beginning address in R0. So here for the destination, R0 is here, R1 is here. Okay, R1 is pointing at the first location. And now, so this is initialization. And after that, I'm going to make a loop, because Again, tomorrow I'm not asking you to make a loop. I didn't teach how can you make a loop. Tomorrow it's just the 3 elements, just to repeat the code. I'm totally fine. But as you know, we don't like to repeat the code in any programming language. That's why we invented loops instead of keep writing the code. I can put the code only one time and I can loop anyway. Okay, so I'm not asking you now to understand looping. Okay, that's something I'm going to teach. But here, what's happening here, as you see here, guys. So I'm going to loop. Here I'm going to have a condition. For sure, I'm going to explain how you made this condition. So what I'm going to do here, I'm going to keep looping. I'm going to keep looping until I find 0, because once you find 0, that means it is the end. Okay. Anyway, if you don't understand much of these examples, that's totally fine, because I'm going to teach them in details. Okay. So what happens here, guys, as you see, look at this instruction. I'm gonna read the byte. I'm going to read the byte using this instruction. I'm going to teach you this instruction, forget it for now, load byte. So I'm going to read the byte from the location pointed by R1. So location pointed by R1, I'm going to read the byte. Then this instruction is going to increment R1. Yeah. This one also is going to, and then this one is going to store the byte. So here I'm going to copy a byte from one array, put it in R2. Then I'm going to copy this byte to the other array. And now I'm using a different pointer, as you see here. And these 2 instructions, I'm going to increment the 2 pointers as well. So this is the body of 4. Imagine this like a for loop. Every iteration. So this is the for loop exactly. Look here. This is the body of for loop. In every iteration, I'm going to read a byte from one array, increment the pointer. Then I'm going to store this value in the other array, increment the pointer, and you are going to keep looping until you find 0, you hit 0. Okay. How you made it? I'm going to tell you how. So what I'm going to do, I'm going to compare. Don't worry about it. Okay. I told you I'm going to teach it. So here in every iteration, I'm going to compare the value of R2 to 0. So the value. So here I'm going to read this one. Is that 0? No. So I have to continue. So I'm going to keep looping until I hit 0. Because 0 means this is the end of the array. So here I'm gonna compare this one to 0. If it is not equal, keep looping. So I'm gonna keep looping until I hit 0, until I find 0. Okay. Anyway, any question? Again, don't. I'm gonna for sure teach how can you do something like that. I already mentioned something like that in chapter 1. I told you if you wanna do comparison, you have to do subtraction. If you have 2 numbers and you want to know if these 2 numbers are equal or not, you do subtraction and then you check the flags. That's exactly what's happening here. So this one here, compare, is going to do subtraction. It's going to subtract 0 from R2. And then this one is going to check the 0 flag to know if they are equal or not. If the 0 flag is 1, that means it's equal. If the 0 flag is 0, that means it's not equal. So we do conditions this way. I'm going to teach the conditions later into this, but that's how we do it. But anyway, for now, try to focus on, because that's what you need tomorrow. Number 1, if you have 2 arrays, if you have 2 arrays, you need 2 pointers. Okay, 1 pointer for each array. Number 2, you need to initialize the pointers, as I did here. Number 3, if you want to read from 1, you can use this one to read from one array, and you can use this one to read the other array. Also, this instruction also is going to update. I don't need, in order to move to the next element, I don't need to write if you use this format, I don't need to write an instruction to update the pointers, because these 2 instructions are going to update the pointer automatically. Any question, guys? If you use any other format, so if I delete this one, it's not going to work, because you are going to keep, you are not changing the pointer. You understand what I'm saying? So if you want to use this format, so here after you finish, you have to write here add R0 and number 1. Add R1 and number 1. So I have to increment the pointer by 1. You have to write it, but here I don't, because the instruction is going to do it for me. Any questions? Anyway, do your best for the coming. Number one, what I'm expecting from you. Number one, you need to read this part about the addressing modes. Okay, you have a lot of examples. I'm gonna post the video. Best to I give it enough time, so you should understand from the example. Okay, you should understand the different instructions. Okay, or the different format for reading memory, and then you have to do the lab. Okay, you do your best to do the lab. I'm totally fine if there are. I know that, this is the first time you write. I'm gonna ask you to write programs. It's the first time, so but it's just a very simple program anyway. So if you have any problem, we're gonna help you tomorrow anyway. But just do your best to prepare for the quiz. Okay. In the quiz again, I'm not gonna. Just I give you some information. I'm gonna test you. I'm gonna see if you understand, if you understood what I explained or not. That's it. You understand this format or not. Okay. Anyway, so now I'm gonna start teaching instructions. I already taught some instruction, but now I'm gonna be in more details. So as you see here, guys, I'm dividing the assembly instruction we have into some classes. So in the first class here, I'm going to talk about data transfer instruction, arithmetic and logic instruction, shift and rotate instruction, branch and loops. How can you make branch and loops, stack and subroutines? Okay. So let's start with the first one, data transfer instruction. What this means? I'm going to tell you what this means. You remember this exactly. You remember in C language when you did something like that, x equal to 2. Okay. Y equal to n. Okay. This exactly. We don't have equal in assembly. Instead, we are going to use one of these instructions, data transfer instruction. So data transfer instruction is used if you want to copy register to register. If you want to copy immediate value to register. If you want to copy memory location to register or register to memory locations. We don't have the case you copy memory location to memory location. We don't have it. You get what I'm saying? Because again, if you want to do it, you have to involve registers in the middle. Okay, as I told you, all the instruction we have cannot work directly on memory location. So data transfer instruction, as I'm saying here, they are used to copy register to register, immediate value to register, register to memory, or memory to register. Is that memory value to register? Okay. And actually, we have 3 instructions. One instruction is called load. We have load. We have store, we have move instructions. Okay, how they are different? Load instruction is used. Load instruction is used if you wanna copy from memory. So if you wanna copy from memory to register, so you have to use load. If you wanna copy from register to memory, you have to use store. Also, as I'm gonna explain, you can also use load if you wanna copy immediate value to register. Immediate value to register. For example, you want to do something like that, R0 equals 7, something like that. For sure, we don't have equal again. Okay, instead of equal, you have to use one of these instructions. Okay, so this is for load and store. What about move? So move instruction is used if you want to copy register to register. Okay, if there is no memory register to register, you can use move instruction. Move instruction also can be used if you want to copy immediate value to register, immediate value. Okay. So I'm going to give you more details. So what I'm saying here, I already explained this part, guys. I told you, if you want to do any operation, addition, subtraction, whatever, I can't do this way. Okay, why? Because physically, the memory, the hardware does not connect the ALU directly to the memory. So you have to use load instruction to read whatever you want to read from memory, put them in the register, and then you have to do the operation, and then after that, same thing. If you have a result, you cannot just write it directly to memory, but actually you have to write it in a register, and then you have to use a store instruction to write it to memory. Okay, guys. I'm giving you an example. If you want to do something like that, x equal x plus 1, for example, and x is a memory location, and the address x is a memory location, and the address of this memory location is stored in R1, as you see here in this example. Okay, how I can do something like that, as you see here, guys. Number 1, I'm gonna read the content of X. Again, I know this part confusing to students, but I'm just trying to do your best. You will understand eventually anyway. So what I'm saying here, guys, R1 is gonna give you the address of X, But if you put brackets this way, and put R1, so this means the value of X. Okay. So what I'm doing here, I'm reading the value of X. I'm putting it R1. And then I'm going to add 1 to R1, R0, R1. So this one is going to actually, this may not be very accurate. So I'm not adding 1. I'm not adding 1 to X. I'm adding 1 to the value of X, And then I'm going to return it to X. You understand what I'm saying? Is that okay? So I have to read the value, put it in R0, and then add 1, subtract whatever you want to do with this value, and then you have to return that. Any questions? Okay. Yeah, so I think I summarized what I did. Number one, you have to, because we're gonna do this way all the time. If you want to do any operation on memory, you have to load, you have to do the operation, you have to modify, okay, and then you have to store it back. Okay. So the first instruction we have here, I'm gonna give you more details on this. I already explained some of them for sure. The first instruction here is load instruction. And the one I explained right now, load, when you say load register, okay? And for load register, guys, here, as you see here, there should be 2 operands. It comes with 2 operands. The first operand here is a register. The second operand here is a memory. So register and memory. And then you are gonna copy from memory, put it in a register. Very simple. Is that okay? So this one is expecting 2 operands. Here is a register, here is a memory. And then you copy from here to here. Be careful, guys. When I say memory, I mean one of the 4 or 5 formats I explained before. When I say memory. So I mean this one, I mean this one, I mean this one, I mean this one, I mean this is, any one of them should be okay when I say memory. Most of the time, maybe just to make it easy, I'm going to use this format, but that doesn't mean I cannot use the other ones. No, you can use any other format of memory. Okay, guys. So here you have to have a register. Here you should have memory, any format of memory. Okay, and then here you are gonna, this instruction is gonna copy a word from here to here. A word. This instruction is gonna be a word. Word to word. This is a word, and then I'm going to read the word from this. Okay, guys? From this address. So that means from this address, and next one. I'm going to take 4. Any questions? Okay. Store, it's exactly same thing, but you have to use store. Also, here you have to put a register. Here you have to put a memory location, a memory, any format of memory. And what the store is gonna do, you are gonna copy a word, 32 bits from here. You put it in memory. You copy it here. Any questions? Something like that. I give you here. I don't need. I'm giving you a numerical example just to understand better. For example, here R0. Where is? Yeah, here you are gonna read load, you are gonna read from memory, put it here. R0 is storing this value. So R0 is here. So that means I'm gonna read the word from here. Store it in R1. When I say a word from here, I mean this one, next one, this 4. So I'm gonna read this 4, I'm gonna store them in R1. Is that okay? How you store them, little Indian or big Indian, it's not a big deal, okay? So I think this, most of the time, we're gonna go with little Indian, but this, you are gonna store this 4 anyway, okay? Using little or Indian, whatever. This one, because this is, when you put, this is little Indian, because you take the smallest address, but whatever you put it in the least significant byte. So here, little Indian. But again, it can be big Indian, okay? Here, store, it's exactly the same thing. So here I'm gonna copy R1 to this location, R0. Assuming this is R0. Okay. So what's gonna happen? That means I'm gonna write to this one and this 4 location. So I'm gonna write R1. That's exactly what this instruction is gonna do. This instruction is gonna write R1 to these locations here, 4 locations here. Assuming R1 is storing this value. So here we have 4 bytes, and also we have here 4 bytes. I can store 4 bytes to 4 bytes using little India, big India, any Indian is okay, as you see here. So I'm gonna take here. Okay, guys. Yeah, this is just an example I have just explained to you before, and I'm gonna. That's what I told you. I'm gonna fix this one. Okay. So here, I'm telling you here, you are gonna, if you wanna add 1 to a memory location, you have to read it first. So as you see here, number one, you have to load the address. You have to store the address in R1. Number 2, you have to read the value. You have to read the value, put it in a register, and then ALU is gonna increment by 1, store the result somewhere, and then you have to return it back. Anyway, thanks. This. Any questions, guys? Okay. I know maybe the first time you write a program, you will be confused. That's totally fine. By the way, as I told you before, if the line does not start with a label, please leave a distance, leave a space. Otherwise, you are gonna write load instruction, for example, and the compiler is gonna tell you, I don't know what this instruction is. You got what I'm saying? So you need to leave a space if there is no label. Otherwise, you are gonna get a lot of errors.